All right, everybody, this is our last section for 1010, section 9.6. That is solving exponential equations and log equations. So here is the routine. Your goal is to get, if you look at this first one, here's a picture of them all. So let's move over so you can see what I'm doing. Okay, we're looking good. Your goal is to get the same bases. So you might have to change one to the other or to another one. Now there is no 9 to some power to give you 27. So can we change 9 to 3 to the second power and put the x next to it? And change the 27 to 3 to the third power. Okay, that makes the bases the same. Remember, the goal is to get the bases the same. If they're the same, cross them off. And you now have 2x equals 3, and x is 3 over 2. Okay, let's do that again on number 2. Now, eventually, you're not going to be able to do that, and I have to show you the log routine. So this particular one, 4 to some power will give you 16, 4 to the second, and then we already have 4 there. So the bases are now the same, cross them off, 2x is equal to 2, and x is 1. Okay, let's go down further. Now what happens if you cannot convert these bases? Okay, so what you can do is you can use something I taught you, the log. You can put log in front of each side. Okay, now, if you have log over here, that means that this exponent drops down to the front. X minus 2, put log 7 next to it, equals log 60. Now I'm simply solving for x. So it's really pretty straightforward. Divide both sides by log of 7. And we now have x minus 2 is equal to log 60 over log 7. And add 2 to both sides. So x now equals log of 60 over log of 7, big plus 2. Remember, you only use this method when you can't make the bases the same. So obviously, we're going to do this again, because you need to see it at least twice. Now, you cannot do 2 to some power to get 10, so you go log. Bring the exponent to the front, x log of 2 equals log 10. Divide both sides by log of 2. Okay, and x equals log 10 over log 2. And use your handy dandy calculators. Go to 3 decimal places. All right, next one. Now this particular one, you could use either method to get the same answer. You can use the log, it does work, but making this to 2 to the 4th power will make it so much faster. I wish I had enough room on this board to show you the other way to get the same answer, but I don't. But you can put log and log. So these cancel. X plus 5 is equal to 4. X equals negative 1. And negative 1 plus 5 is 4. 2 to the 4th is 16. Okay, moving down. Let's do it again. Except this time you can't do 4 to some power to get 8. You have to do 2. Okay, to the second power. And you got 3x. This is 2 to the third power. And you have 2x plus 1. Cancel the bases. Moving it over a little bit, you got 6x is equal to 6x plus 3. Subtract 6x from both sides. And you get 0 equals 3, and it does not, so there is no solution. Just happened that way. Let me pull this back so you can see the whole thing. And you can actually print a picture. Okay, turning it around. We have 2 more problems. You've done the hardest stuff. This is easy now. Let's get this to stay. Okay, here we go. Changes from log form to exponent form. That would be 4 to the negative 2 is equal to x. And x is equal to 1 over 16. Now we have a different problem here. One I've never taught you. What if you have ln of something equals 2? To get rid of the ln, you actually have to use e. E to that equals e to that. E and ln cancel. Not next to, make this in a power form. So you get 3x is equal to e to the 2. Divide by 3, x is equal to e to the 2 over 3. This problem is generally not on your final exam. So that's the story. There it is. We're done. Thank you. Bye.